Assalamualaikum and a very good morning to all. Okay, today I'm Hussein bin Haniba. I'm going to discuss another topic on fundamental particle of atom. So guys, stay tuned with me for the entire of the lectures. I'm on this particular topic. I'm going to discuss about the isotopes, mass abundance, and also the instrumentations, mass spectroscopic. Those are the important topics that I will discuss on this PowerPoint presentations. So without further ado, let's proceed with our presentation. Yes, we are going to discuss on this particular topic. We are going to look what do I mean by subatomic particles in a one atom structure models, and we will discuss a bit on electric and a magnetic field of a subatomic particle, where this is important, particularly to identify, like we know in the atoms we do have a proton, electron, and also neutron. How to identify those charges? So we will discuss about this based on the magnetic fields of the subatomic particles over here. And of course, the most important topics will be, we're going to discuss about the atomic number and the mass number. This is where I will go into the discussion of the mass spectroscopic later on. And of course, the most important things is about the isotopes. We will look a few example and the graph and calculations to make you clear about this topic. So my next slide will be, let's have a look. Wait. Of course, my next slide, we are going to discuss about few other subtopics. We're going to have a look what we mean by relative isotopic mass, relative atomic mass, relative molecular mass, relative molecular formula mass, isotopic abundance. Guys, do not confuse with all those terms, because they all are referring to almost the similar definitions. That's what we're going to have a look. Okay, this is what you expect to learn of the end of these chapters. Let me put it over here for a while. Those are the topics that we're going to have a look. So okay guys, without further ado, why not we start our topic? So I'm very sure in a very primary level you have learned about an atom. We have few scientists have discussed about the atom models, Bohr, and also a few other scientists. So actually an atom can be consist of course the nucleus at the central part of it, where the nucleus of an atom have a proton and neutron, and a proton and neutron, where it actually the nucleus function to control the activity of an atom. So where it is surrounded, the nucleus actually surrounded by a few shells, where the shell consists, or over here as you can see, this is a small pink dot, is actually referring to the electrons. So this is your nucleus. The nucleus consists of a proton and also neutron, and the shells consist of the electrons. And you must remember, the electron will be keep on rotating through circulating this nucleus, where this model you can actually take it is similar like where our planet are rotating the suns. It's the same model. It's an orbit in the moon, our planet Earth rotating the sun in its orbit. The same go to here. The electron is look like our planet, and it's have a circulating in a one circulate patterns. That is where I call as a shell, and of course is surrounding the center of the atom, which is the nucleus, consists of a proton and neutron. Don't worry, we will go in detail about this later on. Okay, as you can see over here guys, those table shows the relative atomic mass than the charges for the subatomic. So by now you should understand that the atom consists of a proton, and the relative atomic mass is called as 1, and it is having a charge of positive, and it is located in the nucleus. That's generally true. And of course we have a neutron, and so the relative atomic mass is 1. Since it's the name, from the name itself, you know it is a neutral. Neutron is neutral, therefore neutral without any charges, and of course it is located in the nucleus as well. Guys, that's for information. Therefore, when you have a proton and you mix with the proton and the neutron, you plus the proton number and the neutron number, this is what we call as a atomic mass. So of course this is your electron. Electron normally consists of a negative charge, and look at the mass of an electron are extremely small as compared to the proton. Of course, comparisons will be like an Earth, a planet of Earth, and also Sun. So we are much more, the electron are much more smaller than the proton. So as you can see over here, it is located in the orbit in the shell. It is at the shells, and it's rotating the nucleus definitely. If an atom is neutral, please, there is one question over here. When we are talking about neutral atom, please keep in mind, I'm actually referring to a neutral atom referred to a same number of proton in electron. I give you a very simple examples. Let's say we are taking a sodium atom. We have a sodium atom. If you are referring to the periodic tables, you will notice the sodium atom have 11 protons. So since the sodium is neutral, therefore we can say the sodium atom will have a 11 electron as well. 11 proton equivalent to 11 electron, therefore it is a neutral. Guys, please keep in mind, I'm talking about neutral atom. If the atom is not neutral, what do I mean by not neutral? It is have a positively charged or a negatively charged. If you have a positively charged particle, that is what we call a cation. Please take note, when it is a cation, it have more proton than the electron. Therefore, it is not balanced in the number of a proton and also electron. Let's talk about an ion. When I'm talking about an ion, that actually referring to I have more electron than proton. Again, I keep in a refreshment. When I say a proton or cation have more proton than the electron. When I say an ion, it have more electron than the proton. That is what is referred to a neutral atom and a charged particle. So as you can see, this is later, you can have a look. So there are some effects over here. Okay guys, let's further. So now you are agree with me that an atom consists of a protons and also electron and neutron. So guys, what is the proof that shows that it is have a negative charge or positive charge or doesn't have the charge? Therefore we do a simple experiment to prove the charge of the subparticles, to prove the charge of the subparticle. As you can see, this is a very simple experiment. It is a very this is a beam of the proton, electron, neutron. Actually, you are past the proton, electron, neutron through a system, then you have a positively charged plate and you have a negatively charged plate. So what we notice over here, from here, when it is the proton, electron and neutron is bypassed over this line, the electron subparticle is noted to attracted to the positive plate. This indicates electron is a subparticle, subatom that is negatively charged. And also they notice when the proton is bypassed this line, it is attracted or deflected more to the negative plate. This indicates the proton is positively charged. And we notice as well over here, when the neutron bypass these lines, it does not deflected either to the positive plate or negative plate. This indicates that the neutron is a neutral subparticle, doesn't have any charges. Okay, those are the few things about this. This is more complicated. Okay, I will show you how this has been done. How to write a symbols. This is very common. I take a very simple examples of aluminium over here. As you can see over, guys, this is the Al is actually the symbols. You can find this a lot in the periodic table of element. We have a plenty of element. I do take a simple examples. This will be the Al is actually the chemical symbols of the element. And guys, you will always notice the symbol will come with a two number. One with this bigger number will written on the top of the elements, and another with a smaller number. It is actually written over here, the bottom of it, where the bigger number over here, actually, guys, it is known as the mass number. Sometimes they call it as atomic mass, which this is consists of a proton and neutron numbers. And as you can see over here, this is the total proton. Since, as you can see over here, guys, as you can see over here, it is a neutral particle, the atom. Therefore, I can assume that I can say that the total proton number is equivalent to the total electron in this element. Therefore, this is also known as called as an atomic number. So please keep in mind, we have our symbols, atomic mass or molar mass, and also we have the atomic number represent the total proton numbers over here. So how to calculate a number of neutron? The number of neutron can be calculated by base of neutron. As we know, it's a proton plus neutron. So by sub minus of this 27 minus 13, you get a 14 over here, indicate the total number of neutron presented in these elements. So more examples to write it down. This is another example.